Welcome viewers, in this video we'll see the details about sets, relation and function and introduction. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Introduction about set, relation and function. One of the topic available in the mathematics. First we'll see the set. A set is a collection of well-defined objects. Is a collection of well-defined. The term well-defined is very important. Well-defined means it will give the clear-cut idea. The collection of well-defined object is nothing but a set. As the theory of set is building blocks of modern mathematics, one has learned the concept of sets carefully and deeply. Right? So the sets is the one of the modern mathematics. It is the one type of the modern mathematics. We can able to learn the sets carefully and deeply. Now we'll look at the term well defined. That is a very important. Well defined. Set is the well defined objects. A little more deeply. We'll see what is meant by well defined. Consider the two statements. Let us consider the two statements. First one is that the collection of all beautiful flowers in Ooty Rose Garden. Second one is the collection of all old men in Tamil Nadu. Right? The collection of all beautiful flowers in Ooty Rose Garden. This beautiful flower is not well defined. Which one is beautiful flower? We don't know. Similarly, old man. Old man means who are the old man? Whether age greater than 50 or 60 or 70 or 80 is not defined. So these two terms are not well defined. The term beautiful flower and old man are not well defined. It's not give the clear cut idea. Beautiful flower may be differ by differ, right? So these two terms are not well defined. We'll see that what we will analyze more. So we cannot define the term beautiful flower in a sharp way, as there is no concrete definition for beauty, because the concept of beauty vary from person to person, content to content and object to object. Right? So the beautiful flower term beautiful flower is not clearly defined. It may vary from person to person, content to content and object to object. It is not defined. Similarly, we should not consider the statement like the collection of all beautiful flowers in Ooty Rose Garden as a set. Now we can say the collection of all red flowers in Ooty Rose Garden is a set. The answer is yes, because all beautiful flower not well defined, but same time the collection of all red flowers, it's clearly defined. Red flowers mean the flower having the color red, that is clearly defined. So this one can be a set. The collection of all red flower in a Ooty garden mean we can easily say that the flower having the red is nothing but is a red color flowers. Right? Clearly we can define that, so that it is act as a set. But this beautiful flower is not act as a set. Now we'll go for the further analysis. So one may consider a person of age 60 as old and others may not agree. So we can say that old man means those who are having the age above 60. But this condition is not agreed by the all. Someone will say it is above 70, above 80 like that. So there is no specific and constraint definition for old man. Right? We cannot define. So the second statement can be made more sharply as the collection of all men in Tamil Nadu of age greater than 70. So this statement gives the clear-cut idea. The previous one not give the clear-cut idea. Old man means not defined, sharply not defined. Whereas not well-defined object. We don't know who is the old man. What is the age for that? It's not well-defined. But here, the collection of all men in Tamil Nadu of age greater than 70 is clearly given. Those who are having greater than 70 age, that collection of men in Tamil Nadu. So we can easily say that those who are having greater than age 70 in Tamil Nadu, men, that is a set, is well defined set. This clear cut idea, it gives the clear cut idea, right? We can easily collect this data. Those who are all having greater than 90 degree as a men in Tamil Nadu, we can collect the data easily, right? Now the above collection now the above collection become a set because of definiteness of the age. The age is clearly given. The age is the clearly given, so that it is we can say this is the set, right? So from these two statements, Ooty rose garden, beautiful flower, and old man in Tamil Nadu, is not giving the clear cut idea, so not defined well. So we can say that red flower in Ooty garden give the clear cut idea. The age greater than 90 in Tamil Nadu man will give the clear cut idea. Thus, the description of set should be enable us to constantly decide whether the given particular object is available in the collection or not, right? So the set will give the clear cut idea about the object, right? From the statement we come to know the definition clearly, then only it is act as a set. So set is a distinguishable collection of objects. It will not give the general idea, it will give the clear cut idea. Red flowers in Ooty garden is a clearly defined. What are the flowers having red color in the Ooty garden is clearly defined. Similarly, the age greater than 90, the men available in Tamil Nadu greater than 70. The age greater than 70 means clearly defined. Those who are all having greater than 70 age, that collection can be easily done, right? So it is a distinguishable collection of object. It will give the clear cut idea, clear cut definition, then only it is act as a set. So in this video we discuss about the introduction about set, relation and function. We will see what is mean by set, how it is defined, whether it will give the general idea or is clearly defined. If you have the general idea, that is not considered as a set. It will not give the clear cut idea, right? If we give the clearly defined, for example, red flowers in Ooty garden is clearly defined. Similarly, the men in Tamil Nadu, age greater than 70 is clearly defined. Old man in Tamil Nadu is not clearly defined. Old man, we don't know who are all the old man. Their age is not clearly mentioned. Beautiful flower is not clearly mentioned. Red flower means clearly mentioned, right? So the set will give the distinguishable collection of object. It will give the clear cut definition. Then it is called as a set, right? Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the important symbols available in the mathematics. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, symbols available in the mathematics. So this is nothing but a equal to. A equal to B means the A and B are equal. This is not equal. Both are not equal. This refers the less than. This is less than or equal. Here only less than is not equal. It will the value is lesser. This will be lesser or equal also applicable. Similarly, greater than. Greater. 10 greater than 50 means it is A greater than B means A is greater than the B, not equal to B. But in the next symbol it is greater. Greater than or equal. A greater than or equal to B means A may be greater than B or it may be equal to A or B also. Right? So less than or equal, less than or equal, greater than or equal. Then here these three lines that refer the similarly. If any process is there, we can use similarly. Then this refers the symmetric difference. This n refers natural number. W refers whole numbers. Z refers integers. R refers the real numbers. Right? So if we have the process, the similar process available mean we can use this symbol. This is symmetric difference used in the sets. These are all the numbers: natural number, whole number, integer, real. N, W, Z and R. That refers the natural number, whole number, integer and real number. Now we'll go to the some more symbols. So this will equal to, equivalent to, right? First we refer the equal to, A equal to B means A is equal to B, but this is the equivalent. Both are equivalent, same process happen. This refers the union. Is used in the sets and relations. Union. This another one. This opposite of this intersection. Intersection means common to A and B, like that. Then universal. This U refers universal. This is refers the belongs to. Then if the one cross mark is there, mean not belongs to, right? This symbol refers proper subset of. Refer the proper subset of. These are all coming under the sets, right? Union means common to A and B. Intersection means it is union means A and B, both the element, all the elements. Intersection means the common element between A and B, like that. Similarly, universal set belongs to, does not belongs to, proper set of. This refers the proper set of. Then this refers triangle. This symbol refers the angle, right? This is a perpendicular. Perpendicular means 90 degree. The symbol itself we can easily identify 90 degree. This is parallel to. This A parallel to B means this refer parallel to. This symbol refer implies. Then therefore, 3 dots. If the 3 dot in reverse order means since or because, due to this. So therefore we can say like that. This is one statement is there, since, because of this, since or because, right? So this is coming under the triangular or some perpendicular. How the triangulars and others refers. Triangle, angle, perpendicular to, parallel to, implies, therefore, and since or because. Now we'll go for some more symbols available in the mathematics. So this not belongs to, already we discussed. Proper subset. If you have one more line means subset of, right? This symbol refers proper subset. Symbol with one line refers the subset of. Then not a proper subset. This is a proper subset. One cross line is there means not a proper subset. Similarly, subset means this symbol. One cross mark there is not a subset of. This is refers summation. We are going to add all the terms. This symbol refers pi, right? We are going to multiply all the terms. This is addition of all. This is multiplication of all. This therefore, since or because already given. This refers absolute value. These two lines within A, if you write absolute value. Absolute value means whether positive or negative, it will give only positive value, right? Minus 10 means it will give to 10. So this is approximately equal to, right? The double line means equal. Both the lines are, this sliding means equivalent to. One line is straight line, another line is inclined means it is called a approximately equal to. It's not exactly equal, approximately equal. Three lines are mean identically equal to. Some properties are identically equal to. Two lines with one inclined mean concurrent. Then plus or minus. Both are plus, minus is there, but both are there. Plus or minus. We need to add as well as subtract. Right? Addition will give one value, subtraction will give another value. Right? So this is the not a proper subset, not a subset. Summation, sum of all value. Pi, multiplication of all value. Absolute value. If it is positive or negative, it will give only positive. So this is approximately equal, identically equal, concurrent, plus or minus. So in this video, we discuss about the important symbol available in the mathematics. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the how to represent a given set. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, representation of a set. Let us consider the set. The collection of odd numbers can be described in many ways. Now let us consider the set is the collection of odd numbers. Now we'll see how to represent this, the set collection of odd numbers. The first one is the set of odd numbers. is a fine description, or we can understand it well. The first type is descriptive form. The description is given, the set of odd numbers, right? The clear description is given. We can easily understand that this is nothing but set of the odd numbers. Second one, it can be written like this. This set of, this symbol set of 1, 3, 5 is go up to this. There is no finite, this is a infinite. It will go in a infinite way. So these are all the odd numbers, 1, 3, 5, 7 up to that. This is another form. It's called a roster. It's called a ruler form, set or builder or ruler form. The third one is also it can be said as the collection of all numbers x, where x is an odd number. So it is given in the another format. It's called a roster format. First, what we are saying is the collection of all numbers x. We are saying x. In that we are specifying x is the odd number. Right? Indirectly we are specifying. Here it is clearly given in a descriptive form. The set of odd numbers. Here clearly given 1, 3, 5 is go up to that. Second type. Third, we are saying the collection of number x, where x is the odd number. Like that we are using. It's called a roster form. So these three forms available. So we will see these three forms in detail. Right? We will see the all three forms in a detailed manner. All of them are equivalent or useful. For instance, the two description, the collection of all solution to the equation x minus 5 is equal to 3 and 8 refers the same set, right? So the what we said above three are equivalent and useful, all are same. But another description is given here. The collection of all solutions is equal to x minus 5 equal to 3. What happened here? X minus 5 equal to 3 means we can bring the 3 in that side, so that it becomes plus 5. 3 minus 5, 8. So it is 8. X equal to 8. It is indirectly given. X minus 5 equal to 3 means x equal to, while bringing the minus 5 that side, become plus 5. So 3 plus 5, 8. X equal to 8. Or otherwise you can set of x, 8. Like this also you can give. Right? So both are equal. Right? So a set can be represented in any of the following three ways. So based on the above analysis, we can go to the standard format. What are the formats available? There are three different formats are available. The first one is the descriptive form. The first one is called a description. The description is given. The descriptive form, a set is described in words. Right? Wordings are given, described in words. What is the example? First example, the set of all vowels in English alphabet. Right? We are not give the alphabet. Vowels are not given, but the sentence is clearly given in a descriptive words. The set is described in, clearly described in the words. The set of all vowels in English alphabet. Second example is the set of whole numbers. Right? So here the clear description is given. First one is all vowels in English alphabet. Second is set of all whole numbers. Whether numbers are not given, the vowels also not given, but descriptive is clearly mentioned. First is the vowels in English alphabet. Second is whole numbers in set of whole numbers. It's called a descriptive form. The second one is set builder form or rule form. Here the number will be mentioned. These vowels and numbers are clearly mentioned in the second format. This is called a set builder form or rule form. Right? We will see this. In a builder form, all elements are described by the rule. Right? Earlier it is described by words. Now it is described by the rule. See the first example. A equal to set of x. X is a vowel in the English alphabet. Right? So we are mentioning x. The x is nothing but vowels in the English alphabet. Similarly, B equal to x. B equal to set of x. That is, x is a whole number. Right? So the symbol, colon or this line stands for such that. Right? So set of x such that x is a vowel or English alphabet. B equal to set of x such that x is a whole number. Right? Here we are giving in a builder form or rule form. Right? Earlier only descriptive is available. Clear description is given. But here given in a rule or builder form, right? One more form is available. One more form is the roster form or tabular form. A set can be described by listing all the elements of the set. So in the first method, description is given. Clear description is given in words. Set of vowels, set of whole number. But numbers are not given, vowels are also not given. In the second type, rule type, what we have is X. X is belongs to whole number. X is belongs to vowels. But in the third form, roster form or tabular form, all the listing all the elements. What are the elements in the set that is listed in this? So we can clearly see the elements available. In the first type only description is there. Second type it is given in a rule form. But here elements are listed. A equal to set of A, comma, E, comma, I, comma, O, comma, U. So there are 5 vowels available. A, E, I, O, U. So that is clearly given. But in the first method only description given. Second method ruler type given. But here all the elements are listed. Similarly, whole number B equal to set of 0, 1, 2, 3. It will go up to infinite. Right? So here the elements are listed in the third method. Roster form or tabular form, the elements are available. 3 dots is called a ellipse. It indicates that the pattern of the listed element continues in the same manner. See, this is nothing but the infinite. It will go up there. It will continues. That is given. So in this video, we discuss about the representation of a set. There are 3 types available: descriptive form, rule form, roster form. Right? Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the types of sets available in the sets relation function, one of the topic in mathematics. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, types of sets. The first one is empty set or void set. Empty set means a set containing no elements. The elements are not available. The no elements are there means it is denoted by empty set or void set. That is denoted by pi or set of open and closing braces. Nothing available inside. Right? So the set containing no element, it's called a empty set or void set denoted by pi or set of open and close the braces without any element. Then finite set. The number of elements in the set is finite. That is, the elements available in the set is finite. For example, we can say some of the example. Red color flowers. That is defined one, finite one. So we can easily identify red color flowers available in the garden. Or yellow color flowers available in the garden is a finite one. Right? So the number of elements in the set is finite means it is called a finite set. We can easily identify the numbers. Then it is called finite. Right? The age greater than 70. The number of boys available in this class is finite set. We can easily count the number of boys in the class. Number of girls in the class. It is a finite set. The number of boys in a city, that also finite set. Right? Then infinite set. The number of elements in the set is not finite. It's not finite. What is that? The beautiful flowers in Ooty garden is infinite. We don't know which is the beautiful flower. Red color flower in Ooty garden is a finite one. We can easily count what are all the red color flowers. That is the finite one. But beautiful flower mean we don't know. Similarly, the old age person in Tamil Nadu, that's it's a infinite. We don't know who is old age. Right? Similarly, the good boys, the boys having about 70 mark in this class is the finite one. But the students having the some other term means is a infinite. Right? So the best example is red color flower in Ooty garden is finite one. Beautiful flower in Ooty garden is infinite. We don't know which is beautiful. It's not clearly defined. Right? Then singleton set. A set containing only one element. The only one set containing only one element is called a singleton set. Now we'll go for some other types of sets. The next one is the equivalent set. Two sets having the same number of elements. The two sets are available. All the two sets having the same elements is called a equivalent set, right? Then equal set. The two set exactly having the same elements. Same element. This equal set means what are the elements available in the first set also available in the second set. But equivalent set means numbers. Only the number is same. Having the same number of elements. Set 1 having 10 elements. Set 2 having 10 elements. The number of elements in set 1 as well as set 2 is equal. But the elements are not equal. Only the number of elements are equal. That's called a equivalent set. Right? Set 1 having 10 elements. Set 2 also having 10 elements. Both having 10 elements. But the elements are not equal. Only the number of elements are equal is called equivalent set. But equal set means having the same element. Set 1 having 10 elements. Set 2 also having 10 elements. Same element. Set 1, what are the elements available in set 1 also available in set 2. Right? The number of elements as well as the elements are equal. Then it is called a equal set. Right? So there is a difference. Equivalent set means only number of elements are equal. Equal set means number of elements as well as the elements also equal. Then important thing is subset. We have subset and proper subset. One of the important term in the sets, types of sets. The subset. A set X is a subset of Y if every element of X is also a element of Y. Right? What is the symbol? X subset of Y. What is the meaning? Y is the main set. In that X is the subset. What are the elements available in the X also available in Y? So that Y is the X is called a subset of the Y. Right? So the symbol is X is a subset of Y. So Y is the main set. The elements available in Y. So more number of elements available in the Y. The elements available in the X also available in Y. So that X is a subset of Y. Then proper subset. X is a proper subset of Y if X proper subset of Y or X not equal to Y. Right? The X is not equal to Y. Both are not equal. Then it is called a proper subset. Subset means the elements what available in the X also available in Y. So that X is called a subset of Y. But it's a proper subset. Right? Not available. X is not equal to Y. Right? So subset, proper subset is very important. The symbol is clearly given. Here, this side, here, more elements available. Some of the elements in Y also available in X. Right? So that X is the subset of Y. This is a main set. Elements available in the main set. Few elements available in X. So that X is the subset of Y. Then power set. The set of all subsets of A is a power of set of A. This is called a power set. A set of all subsets of A. The A is the main set having all subset. That is the power of set A. That is called a power set. Then universal set. A set contain all the element under consideration. Right? Universal. Universal means it's containing all the elements under consideration. If you take any object, any statement that contain all the element, that is called a the set is also called a under consideration. This is called a universal set. Right? So in this video we discuss about the types of sets available. Empty set means not having any element. Finite set means it will give the clear-cut idea. Red flowers in Ooty garden is a finite set. Beautiful flower in a Ooty garden is infinite set. The beautiful flower we cannot define easily. Singleton set means only one element available. Equivalent set means number of elements are equal. Equal set means number of elements also equal and elements also equal. Same elements are available. Subset means one main set is there. Some of the elements available in the main set available in another set. That is called a subset. Proper subset means not equal. Both are not equal. Power set means if we have the set A, all the subsets of A is the power of A. That is called a power set. Then we have universal set. Contain all the element under consideration without any neglection. We contain all the elements means it's called a universal set. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the algebra of set, one of the topic available in sets, relation and function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the algebra of set. First one is union. The union of two sets A and B is the set of elements which are either in A or in B. So this is simple. A union B. What is A union B? The elements in the A as well as element in the E are grouped together so that it contains either the elements A union B elements are either available in A or available in B. Right? All the elements in A as well as all the elements in E are grouped together. Some of the elements may be common, right? Grouped together, that is called A union B. So that A union B, the elements may be available in either A or in B, right? The intersection of two sets A and B is the set of all the elements common to both A and B. A union B, common. The elements available commonly in A as well as B are grouped together, that is called a intersection, right? So the A union A intersection will be give the elements are available commonly in A as well as B. But here the elements available in the A and elements available in B all are grouped together, right? All the elements are grouped together so that A union B, right? So the A union B may be the sum of the elements available in A, sum of the elements available in B. All are grouped together. But here commonly available. The elements commonly available in A as well as B are grouped together. That's called intersection. Union means all the elements. Intersection means commonly available elements. Then complement of a set. Next one will have the complement of a set. The set of all elements of universal set U that are not elements of A, right? The set of all elements of U, universal set, that are not elements of A, that is A dash. A is the set of elements. A dash means the elements not available in A, that's called A dash. Set difference, right? So it is clearly given. A means set of elements. A dash, the elements not available in A is the A dash, right? Not available. Set difference A slash B or A minus B, right? A is the set and B is the another set. From A minus B means then the elements available in the B is eliminated in A, so that only the elements available in A will be give. A minus will give the elements available in the A is and elements available in the B. The elements what are available in the B are neglected in A. So we will see clearly the difference of these two sets A and B is the set of all elements belongs to A, not belongs to B, right? The set of elements, the more number of elements available in the A, from that the elements of B is subtracted. So A minus B will give only the all elements belongs to A, not belongs to B, right? The elements of the B is subtracted, right? So the A minus B will give only all the elements belongs to A, not B, because B is subtracted. That is called a complement of a set or set difference, right? Complement of a set means the number of elements in A, the number of the elements not available in the A is A dash. A slash B or A minus B means the elements in the B are deleted from the A, so that A minus B will give only the elements available in the A. The elements in the B are neglected, deleted, right? Now we'll see the disjoint junction. Next one is the disjoint junction set. Two sets A and B are said to be disjoint if there is no element common to both A and B, right? Disjoint junction means the set A and set B is available. There is no common elements between A and B. Then it is called a disjoint junction, right? There is no common elements between A and B. Open interval. The set of X such that A less than B less than X less than B is called a open interval and denoted by A comma B. This bracket, normal open and closing parenthesis AB. What is the meaning? X is the set of X such that it is lies between A and B. But A and B is not included because A less than X less than B, right? So A is not included, B also not included. In between A and B is a set. So that it is called a open interval, right? Is denoted by open and closing parenthesis A comma B. In the second one, closed interval. Closed interval, the set of X such that A less than or equal to X less than or equal to B, called closed interval, denoted by square bracket A comma B. What is the meaning? X is the set of X is such that in between A and B, A and B also included, less than or equal to, A also included, less than or equal to B, B also included. So in between A and B also included, so that it is called a closed interval. But here in between A and B, but A not included, B also not included, right? Greater than A and less than B, right? A and B is not included, so that open interval denoted by opening and closing parentheses of A comma B. Here A less than or equal to X less than or equal to B. A and B also included. In between A and B, that A and B also included, that is denoted by square bracket A comma B, right? That is the difference of open interval and closing interval. Next one, neighborhood of a point. Let A be any real number, right? A is the real number. Let epsilon greater than 0 be arbitrarily small real number. Then A minus epsilon, comma, A plus epsilon is called an E neighborhood of the point, and A denoted by A n, capital N with small a comma epsilon, right? So this is the first one. A is the real number, epsilon is the small real number, right? Epsilon is the small real number. So A minus epsilon, A plus epsilon is called a epsilon, called an epsilon neighborhood of the point A, denoted by A n a comma epsilon, right? So there is a comparison between this real number, any real number with the small real number, that's denoted by A minus epsilon or A comma A plus epsilon. This is denoted by the symbol n a comma epsilon. And one more type is Cartesian product of sets. The set of all ordered pairs A comma B such that A epsilon A, this A is the small letter, capital letter, and B epsilon B is called a Cartesian product of A and B is denoted by A into B, right? So the A, B is the ordered pairs, right? A and B is the main set. So A epsilon A, B epsilon B is a Cartesian product that is denoted by A into B, right? So in this video we discuss about the algebra of the set, various types we discussed. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the types of relation available in sets, relation and function, one of the topic in mathematics. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, the types of relation. First one is the reflective. A relation R on a set A is said to be reflective if every element of A is related to itself, right? The relation R, we are checking the relation R for a set A. Every element of set A is related to itself. There is a relation. There is a relation between all the elements in the A. Then it is called a reflective, right? This, yeah, every element of A is related to itself. There is a relation between all the elements. Then the relation is called a reflective. Symmetric. A relation R on a set A is said to be symmetric if A comma B epsilon R implies B comma A epsilon R, right? AB as well as BA both are implies for all AB epsilon A, right? A comma B means is related to R means B comma A related to R means AB also related to A, right? This AB is the subsets that is related to A. Then it's called a symmetric. AB, BA, then AB is belongs to AB epsilon A. It's called a symmetric. Then transitive, a relation R. A relation R is R on a set A is said to be transitive if A comma B epsilon R and B comma C epsilon R and A comma C epsilon R for all A, B, C epsilon A, right? We are checking the relation R for a set A, AB epsilon R, BC epsilon R, AC epsilon R, right? A and B is combined here, B and C is combined here, A and C is combined here. All are implies to R means all ABC epsilon A, right? This ABC R belongs to the A. That's called a transitive. AB, BC, AC. So that ABC implies the A. It's called a transitive. Anti-symmetric. A relation on R, the relation R on a set A is said to be anti-symmetric if A comma B epsilon R and B comma A epsilon R, that is implies A equal to B for all A comma B epsilon A, right? It's called a anti-symmetric. Symmetric means it is only AB epsilon A, but here A equal to B. This is said to be anti-symmetric. The relation on A R for a set A, AB epsilon R, BA epsilon R, and also A equal to B for all A comma B comma A comma B epsilon A. Then it is called a anti-symmetric, right? Next we will see the equivalent. We will see another two more types available. Equivalent. A relation R on a set A is said to be equivalent relation if it is reflective, symmetric and transitive. So what we discussed earlier, three relation, if the relation on R on a set A satisfy reflective property, symmetric property and transitive property, then it is called a equivalent set. The relation is equivalent, right? By satisfying reflective. Reflective means all the elements related to itself. Symmetric means A comma B epsilon A. Transitive means A comma B comma C epsilon A, right? All are related. A comma B is related, B comma C related, A comma C is related. If you satisfy all, it is called a equivalent. Then function. A function f from a set A to be set B is rule which assign each element of A is element of A unique element of B, right? So the A element, if we are checking from set A to set B, each element of A is a unique element of B. Then it is called a function. If f such that A to B, then A is a domain, B is the codomain, right? So this is a function A to B. Then it is called A is the domain, B is the codomain. So in this video we discuss about the types of relation available in the sets relation and function. First type is reflective, that is related, all the elements are related. Symmetric, A comma B and B comma A all are symmetric. Transitive, three elements are available, A comma B, B comma C, C comma A. All are transitive. Antisymmetric, same thing, similar to symmetric, but it is A equal to B. A comma B, B comma C, and A equal to B. Then equivalent. If we satisfy reflective, symmetric, and transitive, that is called a equivalent relation. Then we discuss the function f. If f such that A to B means A is a domain, B is a codomain. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.